let us check the moment of inertia of rectangle first. Concentrate on the question. Determine the moment of inertia of a rectangle about an axis passing through the centroid and parallel to base. Also find moment of inertia about base axis using first principle. So, first of all, you can see in this figure, this is the centroidal horizontal axis, which means it is passing from the CG itself. Similarly, this is centroidal vertical axis, which is passing from the centroid and it is vertical. Now, what we have to find? We have to find moment of inertia about this axis, means parallel to the base as well as passing from the centroid. Now, then after we will calculate moment of inertia about the base of rectangle. Okay, now let us start with the figure first. You can see in this figure, we are taking this rectangular strip. Okay, this is the rectangular elemental strip. Width of the strip is dy. Vertical height of the strip is dy, while horizontal width of the strip is equal to the width of the rectangle, which is b. Now, this strip has cut out at a distance of y from horizontal centroidal axis. You can see. And from the centroidal axis, the upper height of the rectangle is d by 2 and the lower height of the rectangle is d by 2. Or you can see the total depth will be equal to d. Now, what is the area of the elemental strip? It is actually equal to b into dy. Okay, so area of the rectangular strip is equal to b into dy. Consider a rectangular strip of width b and depth d. Also consider a small strip of thickness dy at the distance y from the centroidal axis. We know that what is moment of inertia or what is second moment of inertia? It is equal to, according to formula, area into distance square. So area is dA and distance is y square. So it will give moment of inertia about x-axis, means this axis, centroidal axis. Where dA is the area of small strip. So basic formula is ready now, dA into y square. Let us go ahead. Now for moment of inertia of whole area, integrate between limits minus d by 2 and plus d by 2. So why it is minus d by 2 and plus d by 2? So if you are starting from this x-axis, then this is the lower limit, means in negative y direction, so it is minus d by 2. And this is the upper limit, means in positive y direction, so it is plus d by 2. So we have to integrate this formula from minus d by 2 to plus d by 2. Okay, so let's see. So this is the formula of Ixx. It is actually the integration of the same formula dA into y square from minus d by 2 to plus d by 2. Okay, where dA is equal to b into dy, area of the strip. So just replace b into dy in place of area. Limit will be as it is, minus d by 2 to plus d by 2. Now here it is, the variable is dy. So by integrating, b will be constant. So b will be taken out. And what is the remaining integration? That is y square into dy. What is the integration of y square? That is y cube by 3. So limit is minus d by 2 to plus d by 2. Now replacing the limit, upper limit first, then y cube, then replace d by 2 in place of y cube, it will be d cube by 8. And here it is 3 in the denominator, so final term will be d cube by 24. Minus lower limit will again give you minus d cube by 24, as lower limit is minus d by 2. So finally minus minus plus, and final answer will be b into d cube by 12. It is very simple, bd cube by 12. You can see with the help of simplification or in your rough notebook. Okay, so this is the formula for Ixx, which is equal to bd cube by 12. Okay, so this will give the moment of inertia of a rectangular lamina about horizontal centroidal axis. about horizontal centroidal axis Ixx BD cubed by 12, but it is still remains to find the moment of inertia of a rectangular lamina about its base. Okay, so let us see how it happens. See, this is the same figure in which we have taken the strip, horizontal rectangular strip having area B into dy at a distance of y from bottom. Now remember, this distance y is from bottom axis, not from the centroid. In the previous case, the distance is from the centroid, and this is the distance or depth of the rectangle d. This is the width of the rectangle b. Now what we have to find? We have to find moment of inertia of the same rectangle area about base itself. About base means axis passing from the base. What is the area of the strip? dA into y square. dA into y square. Area of the strip is considered as dA and distance will be y from the base. Now, what is the limit of integration? As the distance is taken from the bottom itself, from this axis, it is the limit starting from 0 to vertical distance d. So integration limit is 0 to d. So from limit integration 0 to d, replace the area dA is equal to b into dy. Y square will be as it is. Then here it is the variable y. B will be taken out as it is constant. Then after y square dy will be as it is. Now integration with respect to y from the limit 0 to d. Integration of y square will be y cube by 3. B is constant. Limit from 0 to d. So it will give you the base moment of inertia BD cube by 3. So here you can see there are two formulas for the rectangle. First about the centroidal axis, which is BD cube by 12, and second which is about base axis, it is BD cube by 3. So B means width and D means depth. Unit will be meter raised to 4 or mm raised to 4 or centimeter raised to 4. So you just have to remember this formula. Let us see about the triangle. Now same thing will be happening with the triangle. This is the strip which is at a distance of x from the top vertex. Total height of the triangle is h. You can see this distance, this bottom distance may be h minus x. Width of the strip is dx. Now what is the area of the strip? As the strip is varying from bottom to top, its width may be continuously varying. So it is very tough. So consider a small strip PQ of thickness dx at a distance x from A. Base equal to B, height equal to h for the triangle. Now consider one triangle, small triangle APQ. In this triangle, the base will be PQ. And consider a big triangle ABC. In this triangle, base will be BC. This bigger triangle contains the smaller triangle. So both the triangles are similar triangles. So you can take the similarity ratio like this. Now what is the height of the smaller triangle? That is equal to x. And what is the height of the bigger triangle? That is equal to h. Now make subject as PQ. So PQ will give you BC in the cross multiplication. Then after BC into x by h. Now what is exactly BC? BC equal to base of the triangle, which is equal to B. So replace BC equal to B. So answer of PQ will be equal to BX into H. So we are now getting PQ. What is PQ? It is actually the strip width. So width of the strip is equal to BX into H, as BC equal to B. Now what is the requirement? Requirement is to find the area of this strip. So area of this strip is equal to this width BX into H and height of the strip, which is equal to dx. Let us go ahead. So this is the area of the strip dA is equal to width of the strip bx into h and height of the strip is dx. So now area of the strip is finalized. We have to find moment of inertia of the strip about base BC. So basic formula is area into distance square. Area of the strip is bx into h, bx upon h into dx, as discussed over here. Now what is distance? It is about base, you can see. So distance from the base of the triangle will be equal to total height h minus upper distance x. So from the lower height, lower bottom of the base, it is h minus x. square as it is. So this is the finally moment of inertia, Vx by h into dx into h minus x whole square. Now we have to integrate it is with a limit of 0 to h. So it is the variable of x. So now b by h will be constant. Then what is remains inside? X and h minus x whole square. Expand this term, it will give you h square plus x square minus 2hx. X in the multiplication as it is. Now multiply this x in the bracket. So you will get x into h square plus x cube minus 2hx cube 2hx square into dx. b by h will be as it is. Now start integration. So x is the variable, h square will be constant. So h square will be constant. Integration of x will be x square by 2. Integration of x cube is x raised to 4 by 4. Here it is 2h constant. Integration of x square will be x cube by 3. Limit from 0 to h. Now replacing the limits, then you will get this type of term. You can take LCM h square into h square by 2 means h raised to 4 by 2. First term. Then after x replace h over here, then it is h raised to 4 by 4. Then after replace h over here, then it is 2h raised to 4 by 3. So answer will be b by h 6h raised to 4 plus 3h raised to 4 minus 8h raised to 4 by 12. This is the actual LCM calculation. LCM will be 12. So by simplification, 1h from this is cancelled out and final answer will be bh cube by 12. It will give moment of inertia about base BC. So moment of inertia about base of the triangle is bh cube by 12. In the rectangle it is bd cube by 3 about the base. Let us see moment of inertia about CG now. Now this is the new equation. What is BC? What is BC? BC is the base of the triangle. What is XXG? It is the centroidal axis of the triangle, means axis passing from the centroid of the triangle. What is A? A means area of the triangle. What is D? D means distance between two parallel axes, means the base of the triangle and the centroidal axis of the triangle. The distance between these two axes, parallel axes, is known as D. Now this equation is known as parallel axis theorem. You can see over here parallel axis theorem. A parallel axis theorem itself a separate theory. We will discuss it in the later lectures. So just remember this formula now onwards. IBC means moment of inertia about base is equal to moment of inertia about centroid plus AD square. A means area of the particular part and D means the distance between these two parallel axes. We have to calculate IXXZ, so make it as a subject. Then it will become IBC minus AD square. Now what is IBC? We have already calculated BH cube by 12. Minus, what is area of the triangle? It is 1/2 base into height. What is D? It is the distance from base to the centroidal axis. Now where is the centroid of the triangle? Just remember, it is h by 3 from the base. Okay, so it means distance from base to the centroidal axis is h by 3. So here it is h by 3 whole square. So by simplifying this equation, you will get bh cube by 12 minus bh cube by 18. So by doing LCM calculation, you will get IXXZ equal to bh cube by 36, which will give you moment of inertia about the CG, which is parallel to base. So here we have derived two formulas for moment of inertia of rectangle and triangle. In the rectangle, moment of inertia about CG will give you BD cube by 12 and moment of inertia of the rectangle about base is BD cube by 3. While in the triangle, moment of inertia about the base is BH cube by 12 and in this case, moment of inertia about centroidal axis will be BH cube by 36. Generally, we will use moment of inertia about the centroidal axis only while calculating numericals. Okay, so guys, that's it for today's lecture. Just practice out these two these two derivations. These two derivations are actually very most important from the exam point of view. In the next lecture, we will start some other theories and some numericals also. Till then, goodbye students. Thank you very much. Do practice.